Continuing on with section 8.1 part 1, let's review how to simplify some rational expressions. Now remember, many math classes ago you learned how to reduce 12 over 15. 12 over 15 is the same thing as 3 times 4 over 3 times 5, and then you would reduce the 3's because 3 divided by 3 makes 1, which means that the result would be 4 over 5. Right here. Okay, so that's great. Now let's apply that same thinking to this expression. So we have 2x minus 6 over x squared minus 9. So we're going to figure out what would multiply to make the numerator, which would be 2 times x minus 3. And the denominator, we've seen that before, that's x minus 3, x plus 3. That's the difference of squares. It's the easiest kind of factoring you can have. All right, now this is multiplication up here, and this is multiplication down here. So we've factored. We figured out what factors make these values or these polynomials over here. But now we can reduce because x minus 3 is in both of them, right? And it's multiplied, and there's a big division bar in the middle. And division and multiplication are inverses of each other. So this is going to be 2 over x plus 3. And you're done. Simplified. Easy as that. All right, so to reduce an algebraic fraction, which is what we just did on that right-hand side, you must have the factored form of the numerator and the denominator. You must reduce factors only. In other words, when I looked at this problem, I didn't go, oh, 6 goes into 9. I didn't do that because this is division in the middle. Division is the inverse of multiplication. So you have to find the factors first and get them multiplied. Then you're allowed to reduce, not before. So always find your factors. Never reduce just the terms. All right, and that means you're going to have to know how to factor pretty well to do these problems. So this is x plus 2 over x squared, what was it? X squared minus 2x minus 8. Okay, so I need to factor. Now the numerator doesn't factor, so it's just x plus 2. That's all you're going to get out of that. The denominator, I need it to factor. So x and x, how about plus 2 and minus 4? Will that work? Check it in your head. First makes x squared. Last makes positive 2 times negative 4. That's negative 8. That's good. And then the hard part is the outers and inners. Outers is negative 4x. Inners is positive 2x. When you add them up, you're going to get negative 2x. So this works. All right, then you're going to reduce because now it is multiplied, right? So you can say this whole thing up in the numerator divides away with this whole expression down here. And what does that leave you with? Well, when you divide x plus 2 divided by x plus 2, what you're really making is 1, right? It's 1 over 1 if you like. But nobody would ever write it that way, right? Because that's just annoying. So what we would write is 1 over x minus 4, like that. And that's our final result. And actually, I'm going to put it down here, otherwise it won't fit on the page. All right, now let's do it again. Over here. Let me type it up. There we go. All right, so now I'm going to have to factor both the numerator and the denominator. Okay. All right, so let's start up with the numerator. I need x and x to get me the x squared. One of them is going to have to be positive and one's going to have to be negative. That's how I'm going to get negative 14 in the back. Well, 14 is either 14 and 1 or 7 and 2. And that's what's going to work because that my outers will be negative 7x. My inners will be plus 2x. Negative 7x plus 2x will make negative 5x right there. And then when I multiply 2 times negative 7, I'll get negative 14 in the back. All right, down at the bottom, I have x plus 2 times x plus 6. That one's kind of obvious. Everything's got to be positive to get you a plus 8 and a plus 12. And 12 is either 1 and 12, 2 and 6, or 3 and 4. And 2 and 6 is the one because it'll add up to 8x for that middle term. Hey, look, I got x plus 2's again. So they're going to divide away. And that leaves you with x minus 7 over x plus 6. And you're done. Next one. All right, so let me type that up 1 sec. right, so there it is typed up. Now we need to factor. All right, so if you look at the numerator, there's two terms there, but it's not a sum or difference of squares, it's a GCF. You can take out a 4 and an x, greatest common factor. That'll leave you 3x plus 2. Oh, then the denominator. All right, so 4, 8, and 12. All of those are divisible by 4. And then I have x squared as well, so I'm going to take that out. That'll leave me 2x squared. Let's think. Plus x minus 3, right? Okay, beautiful. So let's see, does this factor anymore? So let me retype the whole thing. And then to check out that denominator, what I want is to see if this becomes factorable. So I'd like to know what that factors to. Well, 2x squared is 2x and x, so I know that's going to happen. And it's just a question of how to make it so that the middle term is 1. So let me try minus 3 here and plus 1 there and see if that works. First would be 2x squared. Outers would be plus 2x. Inners would be minus 3x. That makes negative 1x. Well, it's close. If I do a plus here and a minus here, that'll work. All right, let's try it again. First is 2x squared. Outers is negative 2, because negative 1 times 2 is negative 2. Inners is 3, and negative 2 plus 3 makes positive 1. There you go. And then the last is plus 3 times minus 1. All right, now I just have to reduce everything I can. So I noticed that this 4 and this 4 are multiplied, so they can actually divide away to 1. And then I have an x and an x squared right here. So that's going to divide away and leave me 1x left over, right? So it's going to cancel out, if you will, that squared right there. And it's just going to leave me an x. And nothing else reduced, so I have factored that denominator for nothing. So I have 3x plus 2 over x times 2x plus 3 times x minus 1. And you're done. Don't need to FOIL it out. You don't need to distribute. You don't need to do anything. Just leave it like that. You've reduced everything you could, and you're done. Matter of fact, I'm just going to put it in the bottom just so it can all fit. All right, and last but not least, this one. Okay, so let's take a moment and kind of factor by grouping for just a little minute. If we take this numerator, let's just do this on the side somewhere. So let me go back over here. All right, aside. There we go. Okay, so this is, now remember grouping. Group together the first two terms, kind of look at them and say, okay, what do they have in common? What could you take out of those? You could take an x squared out, right? So if you take x squared out, that leaves you x minus 3. Now look at the back two terms. What did they have in common? What could you factor out of them? Well, a 3, right? So plus 3, that'll leave you x minus 3. Oh, very nice. See the parentheses are the same? Okay, so that means you have x minus 3 comes out. In the first term, when you take x minus 3 out, you're left with the x squared part. So that gives you x squared plus 3. Because in the second term, when you take x minus 3 out, you're left with just the plus 3. So that goes right here. All right, so that's the first aside. And then the second aside, actually, maybe I'll just leave it like that. Okay, so we now know that this is going to be what we just found. It's going to be x minus 3 and then x squared plus 3 for that numerator. But now the denominator, right? So do you see how it's backwards from what you want? Do you see how it's 9 in front and x squared in back? That is not what you're interested in having at all. What you would like would be to have it so that the x squared is in the front and then 9 is in back, like it is for all the other problems, right? And actually like it is right here. See how the x squared's in front and the number's in back? See how the x is in front and the number's in back? That's what you want. So what you can do is switch the roles of the x squared and the 9 by factoring out a negative 1. If you do that, what's going to happen? 9, if you divide away by negative 1, will be negative 9, and then plus x squared. But nobody would ever write it that way. So what it'll do is they'll write x squared take away 9. Now, double check and see that I'm right. Negative 1 times x squared would be negative x squared. and there it is. Negative 1 times negative 9 is positive 9, and there it is. By factoring out a negative 1, you cause the polynomial to switch. So everything that was positive, like the 9, becomes negative. Everything that was negative, like the x squared, becomes positive. And it causes a reversal, if you will, in the order of the terms. And that's a good thing, because we want the order to match the order that I have up here in the numerator values. Okay, so this is equal to, now we can still keep factoring, because that denominator, this x squared minus 9 business, is the easiest kind of factoring there is. It's a difference of squares, right? So it's x minus 3, x plus 3. So now my x minus 3's, I have two of them, one in the numerator, one in the denominator, and they can both disappear. Well, they divide, if you will. So you divide and they make 1. So you're left with x squared over negative 1, x squared plus 3, plus 3, over negative 1 times x plus 3. I must have hit my caps lock. There it is. And you're done. You don't need to distribute the negative. You don't need to do any of that stuff. And this was just kind of on the side. There. Just, you wanted to go calculate, oopsie, you wanted to go calculate that factoring somewhere else, because it's going to take up a lot of space otherwise. All right, we are all done with section 8.1 part 1. I'll see you back here for 8.1 part 2, where we deal with the graphs of rational expressions and what those look like. See you then.